Okay, well, for people who are joining us on the live stream, this is a meeting about the design of our geometric scene system for doing kind of Euclid-style geometry and other things. So let's take a look at what we've got here. Does this stuff run, by the way, in what I have here?
It runs in the prototype 12 build.
Okay. Okay, so, and Roger, have you seen this stuff to this level or not?
We had one previous meeting, so okay. I don't know how much different it is from that. That was a while ago.
Okay. All right, so let's take a look. Can we see some basic examples here, just to get us started? If I click this, will I get to the documentation?
Right, so
yes.
Yeah, that link should work, and it should have some examples on it.
Okay. All right. So geometric scene is the way of representing a symbolic piece of geometry. And
Euclidean geometry. It's a very simple notion of geometry.
Two-dimensional, yes.
Okay. So this contains, just to be clear for the, for the Roger team, this contains both things like circle, which are already supported by the rest of our system, circle through, which is not, angle bisector. What is an angle bisector? Is it a thing which has a size, or is it what is an angle?
It's an infinite line.
Okay, so it is. So it's a way. Essentially, it's an alternative representation of a line object in some sense, but specified not by the points that it goes through, but by the points that it is the bisector of the angle between. Is that correct?
Right, and luckily it bisects both the small angle and the reflex angle.
Because it's an infinite full line.
Right.
Okay. Okay. So of the things that are here, there are certain things like circle through, which in principle, for purposes of geometric computation, could be just turned into pure circles. Is that correct? I mean, for purposes of geometric theorem proving, circle through is a different creature than circle. But for purposes of like working out a distance or something, using computational geometry, it could be turned into a circle. Is that correct?
Correct.
If you don't accept parameters. I mean, if it auto-evaluates.
Symbolic parameters.
Yeah. If it auto-evaluates the...
It's not going to auto-evaluate because it's got to maintain its symbolic character for geometric theorem proving. But it could...
There's probably a smooth transition between the two. Obviously, for 3 concrete points, we can find a circle. For 4 concrete points, we might find a circle.
For 3 concrete points, doesn't circumsphere already do that?
Yeah, for exactly 3. Circle through comes with the assertion that, even if we have more than 3 points, they are concyclic.
I see.
And the SSS triangle, you can
So what happens if you give 4 points that are not on a circle? What does it do?
So if inside of geometric scene, if you specify these points and they're not concyclic, then there will be no scene drawn if you're trying to draw a scene. Ian, what's the behavior outside of geometric scene? Is it just
it should just remain unevaluated and issue a message?
This is one of the discussion points, like what happens for such.
Yeah.
Okay, but so let's just take a look. Okay, so this is an example down here, and did you say okay? You think this is runnable, right? So I can.
Yeah.
Actually, let me just open this in the prototype kernel. Okay, and now hopefully, okay, let's go back here. All right, geometric scene, opening in the prototype kernel, and now if I go down here and I get something like this. Just so I understand, put this in here. Okay, so geometric scene of the points A, B, C, and O triangle ABC, circle through ABC, and with center O. O is the midpoint. Is there really a capital P for midpoint?
There should not be.
Okay.
I think that's a typo. Right, you should, if you change the capital P to a lowercase p, it should run.
All those symbols are blue, so this makes me suspect. Can you do dollar version? I mean, there was some issue where it had to be taken out or it wasn't building or something, right? So it wasn't April 19th. That's
That's
that
yesterday.
should be the latest build, right? Yeah.
No, there's one from this morning that, and it's on that one.
Okay, so I can't run this, is what you're telling me. But if I could run it, it would produce this instance here, yes?
Correct.
It could produce a different instance.
But obviously, it's got random numbers, right?
Right.
Although it is unclear to me exactly how that. So you should have a random seeding option.
We do.
Okay, good. You're ahead on that subject. Okay, so then these are the way the geometric scene works is it will have as its first argument, instead of the symbolic ABC O, it'll have actual values given for that, right?
Correct.
Yes, that's what find geometric scene instance does, is it basically fills in those specific values.
Exactly.
Correct. And also values for some auxiliary points and variables that get introduced internally.
I don't understand that. I mean, so that there's some kind of cache thing inside here. But I mean, the visible part of this is that it has filled in, instead of this geometric scene that has, wow, that's weird. That's what the heck is that? Oh, that's I see. If I made this a standard form cell, still like, well, why did you make this an input form cell? I don't quite understand.
In standard form, it is that image above.
Oh, I see. In the official version. Okay. All right. But so this is what it is internally. And you're saying that there's some cache that contains additional geometric resolution, so to speak, that we don't see here. Is that right?
No, there might be points that you need that are still explicitly mentioned.
And what are they called?
So currently they have a geometric point head, and there's some string descriptors inside just for debugging purposes.
That needs some more work.
So
ultimately, they're kind of UUID points.
Yes,
they're
basically
created points.
Yes.
Okay.
And not just points. Sometimes there are scalar quantities. Actually, I'm not quite sure why the radius. Usually for a circle, there's an automatic radius if it's not specified, and I don't see one specified here, so I'm not sure why that's not showing up. Ian,
okay.
Did you?
All right. So,
not a big deal.
Okay. So now, what is this? How did that get find geometric conjectures inside it here? I don't know what this is doing. So find geometric conjectures returns what?
It returns a geometric scene, but now the third argument has a list of conjectures added.
So, okay, so the third argument, you got a lot of background noise there, by the way. So the third argument of geometric scene, you're saying, is so I don't understand what this is. Wait a minute.
It's the fifth one.
Sorry?
The fifth one is the third argument one.
Well,
okay, so there's some conjectures about the scene, but these are not necessarily truths about the scene. They're merely conjectures.
yeah, they're conjectures based on the concrete coordinates and scalar quantities returned by the.
Is that just
guard.
a cache, or is that something that the user would actually care about at this point?
They are fully explicit present.
Yes.
And somebody might extract them.
Correct. For them to show up, they would have to explicitly run the find geometric conjecture. So they would be expecting them.
I mean, outside of the scene, they are not very useful.
I understand, because they relate to the local variables of the
Yes,
scene, among
exactly.
other things.
Yes.
Okay.
So like
What's the difference in geometric facts and geometric conjectures?
Facts have been proved.
Okay. Okay, so then what does it return? What does find geometric facts return? Does it also just fill things into a geometric scene, or does it return something different?
Okay, I haven't seen this one before.
Let's not go there yet. That's a little bit early.
It's it should be outside of the geometric scene, I believe.
Okay, that really doesn't seem right to have one thing called find geometric conjectures, one thing finds geometric facts, and they return completely different structures.
Well, find geometric proof will return a proof object, which is going to be very.
And what are the types of steps that will be there?
That's a different. Let's keep this for another discussion.
Okay. Okay, now we get into the meat here. Okay, so a bunch of these are things which are like equal, except they're not equal.
Well, no, because these are univalent properties, right? They eat one thing.
Correct.
Right? Equiangular is the assertion that this polygon has all equal angles. And
right, I understand. Although one could imagine a case where one might want a second argument, they're all equal and they're all equal to 60 degrees or something, perhaps. I don't know, that's perhaps a silly case. Okay, so these are Q-like functions, except that they're not actually Q functions because they don't force a resolution, because they could have something symbolic inside them.
In this sense, they are like equal. They stay there if they can't come to a conclusion.
Right.
But the question is, making them come to a conclusion for explicit one might be a lot of work for the geometry team.
What does the geometry team have to do with it?
Because I thought the geometry team works with the explicit things, because we are working mostly with symbolic ones.
Well, so the question is, okay, look, region convex would be a good example. So if I have some region specified by some, discretization of a picture of a flat picture of an elephant or something, how do I determine in our computational geometry system, how do I determine if that's convex? Roger?
I mean, we have I don't know, we have a convex region defined. Who's defined this?
Well, it isn't defined yet. So let's be very clear. Let's just play around and just understand what we're talking about, okay? So let's say I do this. How do I make that into a region? Region discretize? Roger?
Image mesh.
Yeah.
Okay, well, actually, what I want to do is color negate that. Okay, so now I've got a mesh. Now, I want to find out if this is convex. How do I do that?
But there is no released function yet.
Okay.
So you can use the definition, but there'll be a lot of work.
Okay, but I mean, is that in the works for?
Yes.
Yes. Okay, fine. Okay. All right, so that's an example of one that is non-trivial, because if you've got a list of points, it's pretty easy, and I think that the geometric scene team could implement that for a list of points. But for a general case like this,
I mean, it's never going to be convex, so it's always you could just return it constant false.
What do you mean? If you have
a point, it's
polygon,
never going to be convex.
Okay, okay. I mean a polygon.
Right. It's already, we already have it implemented inside a geometric scene. It works for polygons.
Right, but it clearly doesn't work for meshes, and we won't expect it to, but that's something that's coming from the computational geometry effort.
And we implement it for polygons.
Fine. But, yeah, whatever. Okay, so something like...
It needs to be very fast. It needs to scale. It needs to be robust.
Yeah, fine. But I mean, in terms of the code path here, what we're talking about, that the main issue here is we've got things that in order to fill out our geometric proving system, we need certain primitives. Some of those primitives will have been reached by the computational geometry team, will be blindingly fast and will work on anything, but some won't have been, but are still needed in order to have this geometric proving system actually be sensible.
It's not so much about primitives, it's more about relations and properties.
Okay, fine. But I mean, is that a fair summary, or did I get that wrong somehow?
Well, I mean, the question is, do we need these to all be primitives, right? I mean...
I understand. I mean, the alternative would be geometric property with a string.
Right.
Right. And I don't know the answer to that, but if they are in the path of what Roger's team is going to do anyway, then we might as well introduce them as primitives, but have them not yet work on more ornate kinds of constructs, you know, if we think the design is right. But let's take a look at what some of these are.
A lot of them makes no sense. I mean, equiangular, you know, so is a disk equiangular?
It would only work for polygons.
Right. And
I mean, like we discussed last time, I mean, during those meetings, so those, you know, we needed first to group those, you know, those property or those primitive based on the object, you know, some work for polygon, some are not that general. Right? So that's one point. Some are just working for line, for point, right?
Yeah. So
does it work to make them actually be evaluatable, or are they just statement like subset or, you know, some inert object?
I'm sorry, what are you saying? So you're saying, wait a minute, they are intended to be inert on a symbolic object, right?
Not necessarily, because we do symbolic computation on the geometric object. So if you give, you know, a line with, you know, symbolic, you know, value ABC point, we actually compute on that. We return a statement.
Oh, sorry, what's an example of this?
I mean, region equal and
or arc length of line of, you know, let's
exactly.
say B, C, D. Sorry, you need the less around the A, B, and the C, D, right?
Okay, all right, okay. So you do mean explicit coordinates. You don't mean symbolic points there.
Well,
Yes.
I mean...
Right, okay, beautiful.
Right, so,
okay.
So sort of one of my concerns about the relations on points, right, is that these are very, very general names, which don't even sort of make sense in general, right? Clockwise, that's not...
No, that's crazy. That's not going to make it.
Okay.
But I mean, the question is, do we want an equiangular polygon predicate, basically? Or do we want to call it, so that would be equiangular polygon, you know, which is probably the right name for it. Do you agree? Do you disagree?
I agree. And that's what we've been introducing now. We build polygon polyhedral subsystems. And if they only apply to that, they should have a name that gives you a hint.
But
Right.
Is it confusing that regular polygon is a constructor and equiangular polygon? Is it?
Yes, it's terribly confusing.
So
I'm probably wrong.
Okay, so might as well bring that up here. I meant to introduce and have that discussion later. But the problem is the Q function are sort of useless for anything symbolic,
Mm-hmm.
you know. And so we've been doing up until now to not use a Q ending because they can't be, you know, because they will be liars most of the time.
Yep.
But it would be nice to have another ending for things that are conditional. You know, so
Oh boy, yeah.
You know, so if it's something that's ultimate value is Boolean, I've returned, you know, one proposal is to have them end in C. So I introduce a convention that doesn't have the restrictions of Q, but still gives you a hint.
I mean, I've been unhappy with Q as being obscure over the last 30 years. To have another, I mean, look, another possibility would be to end in test. Which is less obscure. I'm not necessarily claiming it's perfect, but
Right. what I mean, how horrified would you be by instead prefixing is?
I'm not sure.
Right,
I mean,
because
initially very horrified, but look, there's many horrors going around here.
Okay, right. So my objection to test is, I mean, right, if when we're using it as an assertion, then it seems a bit odd.
Yeah. I agree. Well, okay. But if the problem we're trying to solve, so Roger, what do you think about an is? And how many of these do you have? Do you have a whole boatload of them, or do you have?
Well, they come in all kinds of areas, not only geometry, because we have.
Well, I mean, asymptotically equal is an example of one that you've introduced recently, right?
Right.
And that's okay. I mean, that's not.
That's not horrifying. But there are others. Well, there's a whole new slew of inequalities. But
like what?
vectorless equal.
What does that mean?
It means vector ordering, so ordering on vector spaces.
Okay.
Partial orderings.
Okay, but that's not hurting the Q business either.
No.
So,
but then there's function classification. Is it non-negative function?
Right. So here are some examples of things we've been thinking about. Bijective function C, convex function C.
I don't like the C thing.
Okay.
Really don't like it. I really don't like it. I think it's inconsistent with our other conventions. Okay, so this is and I don't really like is bijective function either. I mean, I think that's and I don't really like tests. So we don't have a solution for this. But let's imagine that we had a small decoration that we could give. That would indicate that it is a testing function.
Or Boolean valued, really.
Yeah. I don't know offhand, okay? But I understand the point that there are these things which are kind of a test for whether it is a such and such. But now in the geometry case, I mean, so what we imagine.
A statement.
What's that?
Or a statement. Like when you say x equal y with respect to solve and reduce, it is not a test, it is a statement.
Right.
Right.
And that's been a very nice, that's worked well for 3 decades or whatever. And so the difficulty now is that it is much less obvious that when you say bijective function, that you don't just mean a function that happens to be a bijection that you're now defining here, and that instead you are making an assertion, or you're representing symbolically the statement that this is a bijective function.
Initially, at least, it will not be used in as assertion, but it will have to give conditional. It has to be able to give formulas, things that are not constant, true or false.
Right, I understand. But I mean, so what you're saying is the initial use will be as a test rather than as an assertion.
Well, test in a more,
No, as generating simpler conditions.
Yeah.
I see. Like,
test is the constant.
It's a reduced like a reduced like function, right? It's
right. Right. So isn't really the right thing either. Is it? I mean,
what about Roger's proposal but fully spelled out? Condition instead of C? Makes it a little bit long, but it's pretty clear.
Okay, so what would it be? Bijective function condition. Conditions.
That is
actually bijective condition might not be terrible in that case.
Then should be bijectivity condition.
Yes, that's pretty nice. So then this would become equiangularity condition.
It sounds very advanced.
Yeah.
What? I mean, no, I like that. Bijectivity condition sounds pretty nice to me. If what you want to return is what is the condition for this function to be bijective? If you think that most of the time it won't be true or false, but it'll be some more complicated condition.
Well, at least it needs to, I'm not sure about most of the time. It depends on your prior assumption on the distribution of problems.
Yeah, I understand.
But it needs to be able to deal with that case, and Q cannot.
Well, I mean, look, bijectivity doesn't seem completely crazy for that.
That seems too general.
I think so too.
Why? Because it might not be a function.
Yeah, there are all kinds of bijectivity.
But look, I think your main problem is bijective function because it could be like compiled it's the same parts of speech as compiled function and so on. That's where that runs into trouble. Mm-hmm. Function bijectivity runs into a lot less trouble.
Okay, what about non-negative?
Well, I mean, the obvious thing to do would be that. I mean, it's a little weird because we've got non-negative as a, well, actually non-negative would be okay. I mean, in other words, we could say function non-negative. I'm not certain. These don't strike me as absolutely horrifying, but let's loop back here for a minute to the equiangular polygon business. So first point is, if we're going to do that, it will be more polygon, by virtue of that naming convention that we just talked about, it will be polygon equiangular.
That wouldn't be bad in my mind.
Yeah, I was just going to say that I like that.
I do too, because it's in spirit of, so we've done that for the region functions. If it applies to that full level of generality, they typically have region first.
Fine. All right. So that's a possibility there. So let's look at, okay, so let's go down some of these. So this will be polygon equilateral.
Mm-hmm.
And I personally, these are concepts that have been around since Euclid. Let's give them frigging symbol names. I mean, I just don't think, I don't know. Roger, do you want to comment on that point?
I think that there are many names introduced through history that then disappears. But these ones are fine.
They've been around for 2,000 years. They're going to stick around.
For triangles, yeah. For 2,000 years, they've been applied to triangles.
Well, this means it's a regular pentagon, right? It's an pentagon with all the sides equal, doesn't it? I mean, in that,
right.
Well, not necessarily regular, but all equal length sides.
Yeah. No, these are fine. See, these are even useful, slightly useful in actual geometry.
Okay, fine. All right.
Well, just think of parallelograms.
Oh yeah, right.
You can have.
Okay, yes, I got it. I was being stupid. Okay. All right, let's keep going here. So what on earth does clockwise mean? Okay.
That's probably one of the hardest.
Right.
Maybe let's put this one off for later.
Well, I mean, why isn't that essentially points clockwise or something?
Yeah.
It'll most likely be applied to the vertices of a polygon. So despite it not being technically true that polygons can be oriented, we might want to accept input with head polygon.
fine, but okay, that doesn't strike me as okay. So collinear then becomes points collinear.
That's fine.
Is that wrong in any way? No. I mean, it seems reasonable to me.
No.
Okay, so we've got similar kinds of things here. Equal angles.
This one.
Equal.
Right. See, this I think is horribly named, and
Yeah.
We recently came up with a potential replacement for equal angles. No one seems to like that.
What is the replacement?
So we were going to have what did we call it? Angle partition. So we're going to have a kind of angles kind of straddle the boundary between a measure, angle measure, and the actual physical object. So there's going to be kind of a constructor where we have the angle partition, a list of points, and followed by a single point where the angle actually is, and there would be an assertion that the list of points would be in some sort of counterclockwise order.
This is way too complicated. What is this condition here?
I have an entire section on this topic below this section.
Okay, all right.
Right.
Okay, fine.
Basically, if we want to trisect an angle or something, insect an angle.
Okay, well, maybe, some of these things. So one question is whether every single obscure thing like this gets an actual symbol name, or whether we have a fall through somewhere that is some kind of geometric property where you can throw, random things into a string. I don't know what's a good idea there. I would prefer not to have to do that. I would prefer to just decide, this is kind of what Euclid used and what people have used since, and yes, it's 20 functions, but let's just put them all in. But if it's too unbelievable, at some point we could say, is it, we could have something that says, is it an Apollonian packing or something? And that would be a silly thing for us to have. Okay, let me ask a different question.
So do you in general find with the example from above where despite the naming points, you stick in a polygon? So if this is generally allowed, then that might be a solution.
Okay, but I've got a different comment. Some of these things are essentially mini, they're assertion. Okay, so you build an assertion out of these primitives, right? But these primitives, any one of there's a certain number of these primitives that are genuinely primitives. But then you can build all kinds of other assertions out of collections of those primitives. And you could build an arbitrarily complicated assertion out of collections of these primitives, but it would not be named as a primitive. So my question is, go ahead.
Most of them, I don't see anyone here that is a primitive in the sense that if you specified all the points, it depends on the input. No, but most of them specify sort of a feature, right? So they constrain the set of possible regions.
Yes.
Space of
potential. Well, these are relations. So yes, they absolutely do that. But what I'm saying is there must be a derived relation, okay? That is, those things are pairwise tangent and they're parallel and whatever else. There's a derived relation. And I'm saying, I don't know which of these are, can't be derived from each other versus which of these are sort of higher level relations, which could be handled in a different way.
But I feel like for the intended audience, it is pretty important that we are be able to state the scene more or less as a textbook gives it. And not
I agree, but I'm arguing for
differential geometry to rewrite it.
No, I understand that. I'm arguing, let's imagine that there's something like pairwise tangent, okay? That is really derived from two other properties, and it's this is true and that's true, and this is true for all that, et cetera, et cetera, et cetera. Am I making sense?
Yeah.
Then my question is, we could imagine some mechanism, I don't know what it is yet. I mean, clearly we could then define, pairwise tangent, whatever it is, of, vars, colon equals blah, blah, blah. It would evaluate.
But this might catapult it in another complexity class.
So pairwise tangent, does that take a point? So it takes two things or a list of things and a point, or just
mutually tangent would. Pairwise tangent, if you have three or more objects, there would be multiple points of tangency potentially.
so?
Okay, but the thing I'm trying to understand is, you could have an infinite number of these kinds of, it's mutually tangent, and it's this, and it's that, and it's whatever, right? You can have an infinite number of relations, which are built
not
up.
really, not really.
Okay.
Like for all practical purposes, say 100 covers every single geometry textbook.
Okay, but is there some theoretical reason? If I think about these things algebraically, is there some theoretical reason to think there's a certain collection of relations about polynomials or whatever, and this is it, and there's no more, or is it? It's sort of a unbounded, because clearly, if we were going to give criteria about polynomials, for example, there's an infinite collection of possible. The 11th coefficient is greater than 2.7 times the 14th coefficient. There are all kinds of conditions I could give like that, and I could name that the kind of the balanced 11-fold condition or something, and I could give it some explicit name, but that would be kind of silly. Is this making any sense? I'm just trying to understand which of these are sort of fundamentally primitives and which of them are somehow derived from other primitives, and then I'm trying to understand how would we name the things which are essentially the derived relations.
But this will depend on your axiom system and makes it not clearer to a normal user.
No, but Michael, look, if you say A, B, and C are congruent and such is true, right? I'm writing that out explicitly. I could rename that conjunction to be some other condition called foo, right?
Yes, but I feel like this misses the point. The point is there are 100,000 textbooks in geometry out, and we try to be able to represent what they say in their language. We don't try to implement a theoretically possible world, but a very real.
Okay, all right, fine. I understand. I'm still making the point. There might be some obscure geometry textbook out there that uses a relation that we are not going to build in as a primitive. Okay?
Definitely.
Yeah. Correct.
Okay, so then what I'm asking for is, under those circumstances, we have a subsidiary definition. I don't think that way of doing it is quite right, but we have some kind of subsidiary definition. Maybe it's part of the geometric scene structure. Maybe it's in the first argument of the geometric scene. I don't know. Some subsidiary condition, right, that represents this derived relation. Am I making sense?
But why wouldn't you not just define a function that then auto-evaluate and expands to the full set of conditions?
That's fine. That's fine. That's what I'm saying here. You might not want that because you might want to have the thing be able to be sitting there in the expression that you put in as a piece of symbolic stuff that hasn't yet evaluated. I mean, it's almost like, the n value of something. If I have pi squared plus Catalan or something, well, if I define my own constant plus the foo constant, okay, then if I say n of this, right, I'm still going to get foo, but I could define the n value for foo, which will not evaluate symbolically, but will evaluate if I hit it with n. And so I
feel
can imagine
like this is going far too far.
Okay,
this would mean that we need a whole framework for the user to add new definitions so that then the scene code understands this definition without explicitly evaluating it.
I understand. I think it could be done in the kind of precursor argument of the the setup argument of geometric scene, but let's not go there. Doesn't matter. I mean, look, it's clear that a bunch of these are harmless. I'm less, the ones where I don't even know what it means, and where you have to say 8 sentences to say what it is, I'm a little less convinced by. Collinear, yeah, I understand what it is, and it's a pretty simple description, and it makes sense to have that as a primitive. I don't know where you draw the line. How many geometry books does it take before you decide a function needs to be in there versus it's stranded, sorry, we're not going to support it? Am I making sense? Can you answer that question? I mean,
There are around 200 phrases that are commonly used.
Okay. Are we seriously imagining we're going to have all 200 of them?
No, we think kind of we come mostly away with what is here.
So,
Okay.
Stephen, before we go on, I wanted to raise, it's a slightly technical point, but I wanted to talk about parallel and perpendicular. Are we thinking we're going to name these something else, or are we really thinking we might stick with parallel perpendicular? Because
I cannot imagine we want to have the word parallel in there.
No.
right. Yeah, so perpendicular is, let me just provide context. Perpendicular is an existing symbol that, formats as a little perpendicular thing. And
Really?
Yeah.
Upside down T.
And then the thing that should be called parallel by analogy with perpendicular is actually called double vertical bar.
Oh, God.
So which is why I'm just saying maybe we should, so if you do double vertical bar of AB, then that Unicode...
Well, I'm not even clear. Yeah, I mean, that is the Unicode character.
That is the Unicode character for parallel. It doesn't look particularly... you'd need to do 2 boxes and full form of the 2 boxes of %14. And I'm not sure if we gave it an actual long name, but of course, the long name is double vertical bar.
Yeah.
Right, but if you look up the code point that this corresponds to, this is the code point in the Unicode tables, which is reserved for the parallel symbol. So I'm just thinking we should steer clear.
It's pretty insistent that, go ahead.
Yeah, so I'm just saying I think we should stick clear of using perpendicular and parallel by themselves because of...
Let's put that on I understand your point. I generally agree with the conclusion, though not necessarily for the reasons you're stating.
Okay.
I think it would be cool to be able to use this perpendicular symbol to represent that, wouldn't it? Or is it not? Do we not care? I mean, like collinear, is there a notation for that?
Not that I'm aware of.
Okay.
So in the line parallel example, one often speaks about in 3D about parallel planes. We would have a parallel plane parallel or line parallel.
I'm not convinced that line parallel is the right term. Geometrically parallel. I don't know. We once we've got agreement about the general form of names here, we can go and try and deal with detailed ones. Okay. I could imagine we could use geometrically as a prefix to some of these things. I mean, I could even imagine that this one could be geometrically clockwise.
Maybe in general, we should go to the next section to see what is the alternative, because we have...
Although geometrically clockwise has its own issues the moment you leave 2D.
Absolutely. Haven't a clue what it means. Okay. So this is geometric property is the thing where one would have those be represented by strings.
Right.
Okay. Which I'm not a particularly fan of. That's kind of nice.
It has the advantage that multiple things can be done at once.
Right. So there are certain scenes where it's implicitly assumed that, say, all polygons are oriented the same way. So it's nice that you can just in one command say, you define the polygons and you say, okay.
Well, I mean, one could have both things. One could have a wrapper function here, which, gosh, that's getting kind of weird, which is a multiple assertion, right? So, So, I mean, what would that look like in other cases? If one says blah is greater than blah, I mean, what that is, that's an and, basically. But the problem is you have to repeat the thing. You say A is greater than B and A is greater than C, right? Or in a single predicate, you would say some predicate P of A and P of B. No, I'm sorry, and Q of A, right? And the point is, there's no. What does all true do? Does it relate to this?
All true evaluates, I think, pretty immediately.
I think it takes a list, right?
Yeah, it just returns and.
Right. It's and at.
Yeah. Okay. Fine. But this construct of taking, multiple conditions. So this is basically. I mean, I'm writing it out in a silly form, but I mean, like all conditions. P, Q, comma, A. Is basically what that is. It's something that's not the right name, but one could have a general thing, which is, I mean, ultimately, what is this operation? So, given you've got a reducer, you've got, it's kind of a weird operation, right? That takes it's an operation that would take PQR, takes an A and takes a reducer, right? What is that? Well, in any case, that's that's essentially a general multiple conditions thing, which one could imagine using in the way of if one has explicit functions for everything. Does that make sense?
Yeah.
So this is the geometric property way of doing all of this stuff. Okay, what is this? What is that?
For the things that have two genuine different arguments, like where,
oh gosh, then it gets horrifying, right? Then geometric property has to somehow plug the other argument in.
Yeah.
Right.
That's pretty grotesque.
Right. It really only came up with tangencies and concurrencies, but yeah, it's not a great solution.
Okay. Oh boy, we've got quite a lot of stuff to go over here, and we are running out of time right now. Okay, look, I mean, this is at least another 2 hours worth of stuff. What on earth is this? Well, that's not too bad. Roger, do you want to comment on this?
Suppressing messages, I don't see a problem with particularly, but what's the...
I'm a bit concerned about rectangle one.
We already suppressed the message, so for sure those doesn't.
Okay.
There are issues like regular polygon, which doesn't fit the current specification, so that's kind of too far.
Well, that's we. What? I'm sorry. What are you saying?
And then what are those things down there? There are parallelogram APs. What are they?
I don't understand what regular polygon. That's a representation of a regular polygon whose symbolic corners are A, B, C, D.
Right. This is a square with vertices A, B, C, D.
In any orientation at any position of any scale.
Well, and so from the point of view of the rest of the system, I mean, are you imagining? I mean,
so my regular polygon, I think, has some evaluation semantics, but rectangle maps directly to a rectangle box. So I'm concerned about adding.
My point that there is already existing the regular polygon take R theta. There is some confusion during the parsing. I mean that makes sense, but that's fine. But it's, do we need a separate constructors, or do we need to, fill all that in that same constructor?
I don't think we should try to put it in the same constructor. I mean, okay, so there's some complexity here because this is essentially an assertion that the points A, B, C, D lie on a regular polygon.
Yeah.
Very different from the constructor.
Exactly.
Yes.
Yeah, and then likewise for the line stuff above. You know, if you have more than 2 points.
Yeah, I mean, this is really much more of a, you know, regular polygon condition or something.
Regular polygon corners. It's more specific. Or vertices or whatever.
Or did you mean when you said A, B, C, D, are they specifically 4 corners?
Well, if it's a square, yes.
No, I'm
It could be.
It can be anything.
What do you mean by anything?
Well, I mean, you could have at
3
least
vertices, 4 vertices, 5.
right,
But if you have 5 vertices, then it's a pentagon, yes?
Right.
right.
Okay. So this is really an assertion about a set of points that they form a regular polygon.
Yes. But inside of geometric scene, it also works as a constructor, so you can ask for the area of it, and it'll draw it.
Okay. Okay, this is kind of complicated, guys. I mean, as you've realized, and we only scheduled an hour for this, which is obviously not adequate. So let's try to pick this up again early next week. And I think it's going to be a 2-hour extravaganza. Roger, do you want to make any other comments before we, you know, I think we just have to plan on scheduling this and try and go through it. You know, there are going to be a bunch of detailed things.
I agree. I think that's minimum required.
Right.
I mean,
and
there are things that are easy to do, and there are things that are, you know, very, yeah. Let's. I won't prejudge it. I think we just need to work through it.
Yeah, I think that a lot of these, I mean, there's a separate issue, which is what the traditional form of something which is a decorated name ends up being. Because essentially we've got a symbolic representation for a, you know, some expression. I don't know whether you had one in some of these cases here, right? So the question is, what's the traditional form of this? Because the traditional form could be a nice triangle picture, ABC. I don't know what, you know, how you write out circle through. And there may be cases where it is somewhat verbose if you type the thing out. But many people will not do that. They'll either see something closer to traditional form, or they will be entering, you know, natural language stuff to get it. So that the, you know, so when we're trying to protect from verbosity at the, you know, internal level, that may be misguided. Okay, that's the end of what I had to say. All right. Thanks, everybody. Let's pick this up again early next week.
Okay, bye.
Okay, see you guys. Bye.